The interesting thing about Jitendra Malik's recent presentation is the emphasis on learning from video. I think learning from video is the answer of the robotics community to the data scale problem that the large language community solved by tapping the internet. And by learning how to interpret video data into the real world in 4D, the robotics community can actually leverage that same power and the same bitter lesson that language community was able to harness. This is the Nodding On podcast. It's May 4, 2026. This is Krimdelko. For the year, we're down 10.1%. The market is up 6%. We're underperforming by 16.1%. Jitendra Malik is one of the researchers that we have a close eye on because he is working in a field that we care about, which is real world AI or robotics. And he's also an interesting person to follow because he's one of those researchers that I think has enough depth and intellectual curiosity to also keep the curiosity of the listener or the follower alive. And I think that's important. Like you don't want to just become a NPC, looking at charts and listening to people and sort of making your decisions almost automatically. Like you want to have some inspiration. I think that comes across with Jitendra. So in his recent presentation, he talks about the robotics problem, and the robotics problem is a data problem, and the data problem comes from the fact that you have almost no data where the real environment is tied to actuator information. So there is, whether you want to do it end to end or not, actually doesn't matter as much in a sense. Or let me rephrase that actually. If you want to actually solve an AI problem, I think the AI problem has to be solved end to end. So you have to go from input to actuator. Whether you do this with hierarchical, leveraging of information and leveraging of learning, that's an architecture solution. But never, in the end, everything is end to end because you literally have to make a decision on the spot from your input. Let's say if you rely on vision, you have to be able to transfer what you see into action. Again, you can have intermediate sort of hierarchical decision-making processes there and that's an architectural question that I don't want to discuss here. But if you want to go end to end, you have to have information about actuators that relates to the scene that you see, and that's what the robotics community in principle is fighting against, because there just isn't any data. There's no data on the internet where you tie making an espresso to the actuator or proprioception data of arms and arms, legs, and elbows and things like that. So now, one way to solve that is by looking at other people or looking at other, looking at other people and learn from them. Now, the problem with that is for anybody who has been, let's say, trying to learn any kind of skill, dancing, ballet, or surfing, or skiing, or jiu-jitsu from video, is that, well, you see how people move, but you can't relate that to your own actuators, to your own muscles, tendons, your own neurons. Like, that's very difficult and just doesn't work. So what you can do, though, you can look at a video and then you can go and drill and then sort of learn, maybe remember how people moved, and then actually drill and then fine tune your muscle memory towards the action that you want to do. And that translation process actually can be engineered. And I think that's what Jitendra is trying to do. So you can look at something and translate that into actual robot actuator data. Now, with that in mind, uh, you know, that opens up two massive avenues. So if you can learn from video into the real world, if you can translate video into real world, if that is actually doable, then you can do two things. One is you can learn from YouTube or similar data sources. But more importantly, second, you can also generate your own videos. You can create a video generation machine. Now, how you do that, that's a whole different, field of science. You can use some Monte Carlo method. You can randomly have, espresso machines doing all kinds of weird things, and then you can sort of, learn out of the, you can basically create your own distributions of data and therefore remove the out of distribution problem. There's a lot of opportunity once you have that. So we had a recent episode where we spoke about this, where it's interesting to think about the following problem. Imagine you had a robot that has a goal, which is make a good coffee. And let's assume the robot knows what a good coffee is. Now it needs to learn the skills necessary to do that, and might not have all the skills. So it will generate its own data in simulation to then train itself on that generated data in order to make coffee. And it could do that by, let's say, use a sort of a probabilistic simulation machine where it could say, look, I have a rough idea of what good coffee is. Now let me do the whole distribution here, the whole range of distributions of how to make coffee, and then learn, and then make a few coffees maybe, and then see how people react, and sort of fine tune myself that way. So this is I think where Jitendra is going with his research. He wasn't talking too much about generated video. He also wasn't talking about AI actually learning how to set up its own data sources. He wasn't talking about those things, but that's us sort of thinking just one step ahead. What Jitendra was talking about is simply the ability to learn from video. That's where the engineering community is right now, and I think that's really interesting. And that's also something that Musk has been talking about for Optimus. And I think we could see in the next 1 or 2 years massive advancements in real-world AI, because the ability to learn from video is accelerating very quickly. Thank you.